Right, welcome back to differential equations, and we're going to do a couple more problems dealing with Laplace transforms here. As soon as I find my pen, there we go. So I just looked at a couple of problems from your homework and grabbed them. So, or problems like the ones in your homework, just to kind of do this. They're all like repeated measure ones, so let's just go ahead and see if we can get a start with this. So here's a y double prime plus a 2y prime plus y is equal to 0. And we are given that y of 0 is equal to 1 and y prime of 1, oh sorry, y prime of 0 is also equal to 1. Okay, so our first step here is take Laplace transforms of both sides. Okay, let's go ahead and do this so people know. All right, and all we're going to do here, right, is we're just going to say, well, this is s squared y of s minus s f of 0 minus, or y of 0 minus f prime of 0. Okay, and we have a plus 2, Laplace transform of our first derivative, so that's s y of s minus f of 0. Okay, plus y of s, and then this whole thing equals 0. All right. So let's combine some terms here. So we have s squared y of s plus 2 s y of s plus y of s, and this is going to be minus, right? What's f prime? Y prime, that was going to be 1. Okay, this is a 2 here, so this is going to be minus 2. Right, and I think that does it for us. Oh, no, we have an S and a 1 here, so let's subtract an S off as well. Equals 0. All right, I think I got them all. So let's go ahead and distribute, or not distribute, but factor. So we have s squared plus 2s plus 1, and this is equal, we'll combine some terms and put them off to the other side, s plus 3. All right. So what do we have? We have y of s, and this is equal to s plus 3 over s squared plus 2s plus 1, which is s plus 3, s plus 1 squared. Now, you may like the shortcut we've been doing in the last couple examples, but that ain't going to work this time, right? Because we're going to say this is a over s plus 1. Since a repeated linear term, it's b s plus 1 squared. All right. So that's my coffee maker in the background. I'm sorry. Okay, let's go ahead and sort this out. S plus 1, right? Because we're just multiplying both sides here by s plus 1 squared. So there's going to be 1 left over here. Plus b is equal to s plus 3. So we have as plus a plus b is equal to s plus 3. Equating the coefficients. Okay. All the stuff with s's in it over here has got equal to the stuff with s's over there. So as equals s. S is area is equal to 1. Okay, we also have that a plus b, right? The constant stuff is over here has got to equal to constant stuff over there. A plus b, it better be 3. Since we know that a is 1, we know that b is equal to 2. All right. So let's go ahead and rewrite our fractions. So we have 1 over s plus 1. Okay. And then plus 2 over s plus 1 squared. Right. Now remember that the inverse Laplace transform, right? This is just going to be 1. Right. So we're taking inverse Laplace transform both sides. So on one side we have y of t is now, right, e of t, well actually 1 e to the negative t, because the bottom, right, it's this f of S minus A, the inverse Laplace transform, is equal to e to the at f of t, right? So 1 over, right, s plus 1 is e to the negative t, okay, plus, and this is going to be 2 factorial, isn't it? Actually, this is going to be 2, we only want 1 factorial, right? We want 2 times 1 factorial. So that's 2 times, right, and then we have t, e to the negative t. And there is our answer for this. And then by all means, if you're still looking at the if you're looking at the table, and you are certainly welcome to do so, I would invite you to go through the table and make sure that these inverses apply with what you know. Okay, so just to double check that. All right, number 5, we have a y double prime. Is that minus 8 y prime plus 16y is equal to t. We are told that y of 0 is equal to 0, y prime of 0 is equal to 1. Okay, so let's go ahead and look at that. So first step, take Laplace transforms, both sides. All right, so here we have s squared ys minus, and then you're going to be doing this so often that you're also going to memorize it, okay? F of 0 minus f prime of 0. Minus 8, right? And now we have to take Laplace transform of y prime, and this was s y of s, okay? Minus f of 0. Don't forget the 8 here. Okay, and then plus 16 y of s, and this was equal to 1 over s, right? Because, or no, 1 over s squared. Because we have to take the Laplace transform of the polynomial here. Okay, so let's put this together. Okay, we're going to have s squared y of s, okay, minus 8s y of s plus 16 y of s, okay, and then we have some other stuff, right? What is f of 0? F of 0 was 0, so that one we don't have to worry about. This part here, this was 1. So this is just going to be minus 1. There's no coefficient out here. There was no f primes here, so this is 0, and we don't have to worry about that one. And this is equal to 1 over s squared. Okay, so here we have y s, and then times s squared minus 8s plus 16, okay, is equal to, and we're going to have 1 plus, right, I'll do it slow, 1 over s squared, okay, plus 1, but we're going to have to divide by this, okay, and that's actually not too bad. We're still going to have to do partial fractions here, but do we want to do it once or twice? I'd say we pretty much always want to do it once. Okay, so this is going to be 1 plus s squared over s squared, isn't it? Okay, so let's go ahead and divide both sides by this. Excuse me, so we have y of s is equal to 1 plus s over s squared. We have s squared, another one. Okay. And it looks like that's like or s minus 4, right? We could just say s minus 4 squared and just factor it as we're dividing. Squared. Okay. S minus 4 squared is going to be this thing squared. All right. And now we have to do some partial fractions. And again, this is how we deal with the repeated roots. So we have an a over s plus b over s squared plus c over s minus 4 plus d over s minus 4 squared. Right, now I haven't done this problem yet, so I don't know what the best way is going to go here. Right? So what I'm relying on is pretty much the way I usually do these problems, and that's to multiply by s squared, s minus 4 squared, and then we'll see how we go. All right, so we have a y of s, and this is equal to as s minus 4 squared plus b s minus 4 squared plus c s minus 4, and then plus d s squared. Okay, and this is all equal to, this should be 1 plus s squared. All right. So we have some options, right? If I choose the shortcut method and say set s to be 0, this term a, c, and d are going to be 0. Okay, so the only thing we're going to have left here is b times 0 minus 4 squared is equal to 1, right? Because plus s squared. So we're going to have 16b is equal to 1. So b is equal to 1/16. All right. How about we set s equal to 4? Okay. So again, we're going to, the a term is going to be 0, the b term is going to be 0, the c term is going to be 0 because 4 here. The d term, right, we're going to have 16, right, s squared, 16d is equal to 1 plus 16. Oh, that looks delightful. So d is equal to 17 over 16, sensing a theme with the 16s here. So when I want to deal with everything else, and it looks like we're going to have to, right? Because the shortcut method is only going to take you so far with a problem like this, so you're kind of stuck. But we have gotten this down from a from a 4 variable, right? 4 equations, 4 unknowns, to 2 variables, 2 equations, 2 unknowns, because we know both B and D. All right, but we're kind of stuck in that we got to go through and do this. So this is going to be AS, right? And then just multiplying this out. So that's going to be S squared minus 8S plus 16. Okay. And then we have a B. Actually, we don't really have to worry about B so much, but we still have to have the terms in here. So it's going to be B. And then here we have S squared minus 8S plus 16. Okay. And then we have a C. And what do we have with C? That's going to be S squared minus 4S. All right. And then D is just going to be plus DS squared. All right. I should have multiplied this S through at the beginning, so I'm going to go ahead and do that now. I'm going to erase this S. And what we're doing is we're just going to change the coefficients a little bit, or not the coefficients, the powers. So we have S squared times this S is going to be S cubed, right? Then S squared, then S. Okay, and this was equal to what? 1 plus S squared. All right. So let's get our cube terms together. All right, I think we have A, this is S cubed. Okay, so the only S cubed term we have is A, and we have no cube terms on the other side. Okay, so there's A. Let's get our S squared terms today. Okay, I don't really need to include any more A stuff, right? Because A is now 0. Okay, so we're just going to have B, okay, plus C plus D is equal to 1. Right? And since we know D and we know B, we're going to be able to get C from this. Okay, so what was B? B was 1/16. D was 17/16, and C we don't know yet, and this was equal to 1. So this is 18/16 plus C is equal to 1. C is equal to 16/16 minus 18/16 is equal to -2/16. Now, normally you'd want to reduce this, but you know what? Right now, everything is in 16ths. So I'm just going to tell you to sit tight on reducing this until the very end, just because it might turn out that it'll be easier arithmetic. It might not, but you know, if you got a whole bunch of things with one denominator, like why are we going to change it in the middle? We'll hold off on that. Okay, so our partial fractions, A was 0, right? So B B was 1/16, so we have a 1/16 1 over s squared, right? C, what was C? We have C, so this was minus 2/16, and this was 1 over, right? C was 1 over s minus 4. And then we have our D, which was 18/16, 17/16, sorry, 17/16. Okay, and D was s minus 4 squared. Okay, so it looks like we can reduce because they're all linear terms and it's not going to be a big deal. Let me go ahead and make that a very clear 17/16. All right, and now we're ready to go. So this is 1 over 16, the inverse Laplace transform. That's what we're doing. Take inverse Laplace transforms of both sides. Okay, so the left-hand side just has that y of s on it. So we're just going to have y of t now, which is the goal. So this is 1 over 16. That's just going to be t. Okay, minus 2 over 16. That's 1 over 8 e to the 4t. Okay, plus 17 over 16. And this is t e to the 4t. Okay, so that's a form that we've done a lot of those in this chapter, and we just started to memorize them. Okay, so there we go with how that's working, and that's our solution to this differential equation. Okay, so great. How about we check the next one? This is going to be number 6. All right, so this is y double prime. Okay, minus 6y prime plus 13y is equal to 0. Again with the zeros. Okay, y of 0 equals 0. Y prime of 0 is equal to negative 7. Okay, so, oh, I know what's 0 now. Okay, taking Laplace transform. So our first step. I hope at this point, like you've watched enough of these videos, it's like, okay, first thing we do is we take the Laplace transform on both sides. Second thing we do is like magic with partial fractions. The third thing we do is untangle the Laplace transform and go back to the t-space, so we inverse Laplace transform, and then we write down our answer. Okay, that honestly, you know, even as wonky as these get, that really is the procedure for each and every one of these. Okay, so all of this really is your skill with looking up things on that table to get the correct Laplace transform and inverse Laplace transform, and that's it. Okay, that this honestly is the quadratic formula of differential equations for you. So if you're ever stuck with one and you know it's of exponential order, we're going to learn some more techniques, and it's like, well, you know, when we had the factor, it's like, well, if it was this way, you factored it this way. If it was that way, you factored it that way. Like, you don't have to do that. We have the key. We have the quadratic formula. We have the way of getting all of this done. Okay, so this is like the most powerful method. Okay, which is why I always teach this thing first. So let's go ahead and do this. So s squared y of s, okay, minus s f of 0 minus f prime of 0, okay, minus 6, this is just y prime. So this is going to be s y of s minus f of 0, okay, plus 13 y of s, and this was all equal to 0. Okay, so let's pull this apart. So we have s squared y of s minus 6s y of s plus 13 y of s. F of 0 is 0. F prime was negative 7. So we have a negative 7 here. Okay, so it's minus 7. Oh, we have one right here too. This was minus. Oh no, we don't have that, because f of 0 is just 0. So we're done with that. equals 0. So here we go. We have y of s, and we have s squared minus 6s plus 13 is equal to -7. Okay, so y of s is equal to -7 over s squared minus 6s plus 13. Now, you're looking at this, I'm looking at this like, this is not going to factor. What do we do? It's not going to factor. Like, it isn't in a form, right? We need some kind of a linear term at best, right? There's a couple of forms that look like s squared plus a squared, right? We also have an s squared minus a squared. But remember, if we have f of s minus a, right? That is going to be e to the t times whatever f was. So maybe there's an s minus a we could put in here. Now, how are we going to find that? Like, oh, great. Why don't we do complete the square? Because this one looks pretty easy to do complete the square on. So if we complete the square on s squared minus 6, not 16, just 6. Okay, minus 6s plus 13, right? This is going to be s squared plus minus 6s. No, not squared, just s. Come on. You got this. Right? Plus 9 plus 4, right? 13 makes 9 and 4. So we could just kind of guess what this is going to be. If this was more complicated, I usually do a plus and a minus business here, and I think that's a good thing to do. But, you know, they clearly set it up as a nice problem out of a textbook, right? And by the way, like, you think, like, he's going to pull shenanigans on us. Like, these already are shenanigans, all right? This is it. So this is s minus 3 squared plus 4, okay? So my Laplace transform here, right, y of s is equal to -7 times 1 over, right, s minus 3 squared plus 4, all right? And we just have a 1 up here. I mean, I guess I could put like I guess I could add 2 and subtract 2, or multiply 2 and divide by 2 here. I think I have to do that because this has to be our thing. So, because we don't have an S, right, we need an A up here, a B. So I think I have to multiply and divide by 2. Okay. So again, what we're doing is we're making this thing fit the table entry. Okay, you're just taking your math hammer and just kind of forging this into the piece on the table that you know is going to work. See, now I've got an a squared and an a. And I believe that's sine. So that's -7/2. I'm gonna double check. Give me a moment. All right. So look here. Okay. No, that's not what I want. I want e to the t. It's like down there in 20. There it is. Okay, this was s minus a. We don't have that. But look at 19. Okay. So we have this b squared here, which is why I put the b up here. So we're going to have e to the at, okay, sine bt. All right, so that's all we're doing is we're just trying to match what we have with one of the entries here. All right, so let's take a look at that. So this is going to be -7/2. We have e to the 3t, right? And this is sine to the 2t. This is all times. Right? And that is equal to our y of t. And the nice thing about this method, well, sort of, is that if we have initial condition problems, right, there's no C we have to go ahead and solve for after the fact. It's all done. This is it. Okay, it all gets done in one step. So there we go with this one. Okay, so not so bad. All right, not so bad. All right, one more and I'll stop this video, 'cause otherwise it'll be too long. Okay, so this is y double prime. Okay, minus y prime is equal to e to the t cosine t. All right, and we're also given that y of 0 is equal to 0 and y prime of 0 is equal to, really, 0? 1? Okay, I'm gonna blame. If we're going to do this in the chapter 4 methods, this is not going to be a fun problem, okay? Because you got to remember, there's certain things you have to remember, like what the answers could be, because you're going to have to apply those answers in your guess, all right? So not a fun part. Okay, Laplace Transform. This is not going to be a hard problem. Okay, so here we have s squared y of s minus s, right? F of 0 minus f prime of 0 minus, okay, we have s y of s, right, minus f of 0. Even if these had things in them, not going to be too bad. What's it equal on the other side? We have an e to the t cosine t. And if I recall, we were just looking, right, at e to the t cosine bt. Okay, e to the at cosine bt. It's right here. Okay, let me move me. Right? So this is going to be s minus a, so s minus 1. Right? And on the bottom, right, we're going to have quantity s minus 1 squared plus, and then b is just going to be 1. Right? I believe that does it for us. Yeah, it does. Okay, I lied a little bit. If we had like other stuff here, this wouldn't be the worst problem that we would have to do, but it would make this partial fraction just a little bit worse. Okay, so maybe we could do one like that instead. But here we go. So we have s squared minus s, right? I mean, it's still going to be, because we have this business, it's still going to be a little tricky. 0, 0, 0. Okay, y of s is equal to s minus 1 over, we're going to have to multiply this out, I'm sorry. S squared minus 2s plus 1 plus 1. So here we have it. We have s minus 1 over, what do we have here? We have s squared minus 2s plus 2. We have an s minus 1 times s. Hold on for a moment. All right, there we go. Okay. So let's continue. So here we have, right, we have y of s. Okay, we have y of s, okay, and then we have s minus 1 over this right here, right? We have s squared minus 2s plus 2. We have an s minus 1. Hey, that cancels, and it does. You can do that. Okay, so this is just going to be 1 over s minus 2s plus 2 times s, right? So again, with the partial fractions, okay, this is an irreducible quadratic, okay? So this is going to be, right, a over s plus bs plus c over this business, s squared minus 2s plus 2. 2 here. So this is just the partial fraction decomp of the denominator here, okay? So when you have irreducible quadratics, we have to do a bs plus c, okay? So let's go ahead and clear our fractions. So we have a s squared minus 2s plus 2, okay, plus bs plus c, okay, times s is equal to 1. Let's just do this with the old way of doing it, regular way of doing it. So here we have an a s squared minus 2as plus 2a plus we have a bs squared, right, plus cs is equal to 1. So just equate the coefficients here. So what are my s squared terms? We have a plus b, and there are no s squared terms over there, so that's a 0. We have our s term. Okay, we have negative 2a's plus c is equal to 0 because there's no s's over here. And then for our constant term, we have 2a equals 1. Okay, not so bad. So a is equal to a half. By that logic, b would be negative a half. Okay, and then c, we got to work a little bit. So this is negative 2 times a half plus c is equal to 0. Negative 1 plus c equals 0. C is equal to 1. Okay, so let's put this thing back together. Okay, we've got 1 half times 1 over s plus b is negative a half plus c, right, 1, all over, and this was s minus 1 squared plus 1. Okay, it was this whole thing, but since we're going to have to put it back into like a, something we're going to need in this form, I just put it back right now. Now, unfortunately, this term is going to be a problem. All right, so what I'm going to do is I'm going to factor out negative 1 half from numerator of negative 1 half s plus 1. Okay, this term is fine. So 1 half times 1 over s, we're fine to take the inverse Laplace transform of this right now. Okay, so this is minus 1 half. Okay, and what do we have? We have s. It looks like we have minus 2 here. If I multiply negative a half times negative 2, we're going to get back to positive 1. S minus 1 squared plus 1. Now, take a look at this. Right? We don't have this. Right? We still have this business here. Okay. So minus b, we'd have hyperbolics, but we don't. Now, we have a b, and then we have an s minus a. This does not look like s minus a, but it kind of does, right? If we break the 2 up into 1 and 1, we'd have a match. Why don't we do that? So we have 1 over 2, 1 over s, okay, minus 1 half, and then here we have s minus 1 minus 1, s minus 1 squared plus 1. And now we're just going to break up the numerator into 2 different fractions. Okay, so this is minus 1 half, right? We have an s minus 1 over s minus 1 squared plus 1. Okay. Minus 1 or plus 1 plus a negative 1. Let's go ahead and do this. So it matches just a little bit. So we have minus 1 over s minus 1 squared plus 1. Now this looks like something that we can work with in our little table thing here, right? We have an s minus a, we have an s minus a, right? S minus 1, and then this is just a constant, right? So if I had to adjust this at this point, I could, because I could just multiply and divide in order to make the b squared match the b, but since it does already, we're set. Okay, and then we had a 1 half 1 over s here. So my y of t, because now we're taking inverse Laplace transform, okay? So this is just going to be 1 half, because it's the constant, minus 1 half s minus 1 over s minus 1 squared plus 1. That was one of our tables, wasn't it? Right? This was s minus 1 squared plus 1. Okay, so this was e to the at, b to the bt, or e cosine to the bt rather. So e to the at, e to the t, 1. This was cosine of 1t. Negative times negative is positive, so positive 1 half. And this one's the sine, right? This is e to the t sine t. All right. This would not have been a fun problem to do with the usual method that they teach you in chapter 4. So sometimes, occasionally, right? Laplace transform actually is a bit faster, okay? Because quite honestly, there's a few guesses you memorize, and then the other one's like, I gotta go look that one up. So this was one I was like, I'm not real sure. I mean, this would have been a guess of thinking that some kind of an e to the t cosine t, e to the t sine t to guess an answer, but I would have had to double check because there may have been like other things that I would have, because it may just be cosine and sine as well. But it isn't. This is it. We're good. We're done. Okay. So let me see. Did I have any more? No, I think that was it. That's a good video at this point. We will continue with next couple, and we'll finish off 7.3 with this. Okay, so there you go. Good luck, and I will see you in the next video.